Good evening, my YouTube viewers. It is Crystal here. I wanted to make another video with you. In this video, we're going to use Python to carry out population hypothesis testing based upon the population mean. And that's what we're going to be doing in this video. And we're going to be using Google Colab to do it. So we're going to go over the 5 steps to perform the hypothesis test, which is 1, you formulate the null hypothesis and the alternate hypothesis. 2, you calculate the standard error. 3, you calculate the t-statistic. 4, you calculate the cutoff value for the t-statistic. And 5, you check if the t-statistic lies in the rejection region. And that's how you carry out hypothesis testing based upon the population mean. So the first example that we're going to go into is we're going to calculate the t-statistic, but we're going to talk about bottles, and each bottle should have 200 milliliters per bottle, and we're going to check to see what happens with that. So we're going to check 10 bottles. So N is 10, that's your sample size. X bar is your sample median, sample mean. It's going to be 199. STD is 0.8, that's your standard deviation. Mu is your population mean, so it's going to be 200. Alpha is your significance level, and it's 0.05. Degree of freedom is going to be 9 because it's going to be 10 minus 9. So the first thing we're going to do is calculate the standard error. Standard error equals STT divided by N to the power of 0.5. So that's a square root of N. So your standard error is going to be 0.253. And then after we've calculated the standard error, we're going to calculate the critical t-values for a two-tailed test. So your critical t-values for a two-tailed test are, it's going to be t-critical equals stats.t.ppf, and that's a percentage point function. 1 minus alpha divided by 2, and then the degree of freedom. And your t-critical is going to be 2.62. Then we're going to calculate the cutoff region. So this is a two-tailed test. So cutoff low equals X bar minus T critical times SE, and cutoff high equals X bar plus T critical times SE. And then so you've got your cutoff region is going to be 198.43 and 199.57. Then we're going to calculate our t-statistic. T-statistic is X bar minus mu over divided by SE. That's your standard error. So your t-statistic is negative 3.95. So then what we want to do is we want to determine if the t-statistic falls in the rejection region. So reject null equals absolute value of t-statistics is greater than t critical, and so that's a true. So 3.95 is greater than 2.26, so that's true. So that means you're going to reject the null hypothesis. The null hypothesis means that the bottles are going to be 200 milliliters. And what I've done is I've used Matplotlib to make a drawing of this distribution. So you can see you've got your t distribution, and then you've got your rejection region. You've got your t-statistic is negative 3.5. Your t-critical is negative 2.26 and plus 2.26. So your t-distribution is in the rejection region, and since it's in the rejection region, then you're going to reject the null hypothesis. And so that means that the values of the bottles are not 200. But what we can do is we can check here. Oh. We can check here. We can make X bar 200. And then say reject null hypothesis is false. That means that you cannot reject the null hypothesis because the weight of the bottle is 200 milliliters. And we can come back over here back to 199. And then we're going to reject the null hypothesis because you can see that 199 of the sample mean is not 200 of the population mean, which is what you wanted. So the next example we're going to use is we're going to do the same thing with a z-statistic. So the only difference between this particular test and the previous test that we did is it's going to be a z-statistic and not a t-statistic. So it's exactly the same. You get exactly the same information. And it says reject the null hypothesis, which is true, and your null hypothesis is a mean of 200, and you know it's not 200. So we can check the X bar here, make it 200. And so the reject the null hypothesis is false. You cannot reject the null hypothesis because the mean of the 200 milliliters is correct. So we'll go back to 199. And you see that we rejected the null hypothesis because the mean is not 200, which is what you want. So what I've done is I've created using Matplotlib, a diagram of this distribution. So you can see you've got the Z distribution, you've got your rejection region, you've got your Z statistic of negative 395, you've got your Z critical of negative 196 and positive 196. And you can see that the Z statistic is outside of range, which means that you have to reject the null hypothesis because it's in the rejection range. So the next thing that we're going to do is we're going to talk about a car manufacturer. A car manufacturer wants an additive that will increase fuel efficiency by at least 3 miles per gallon. So your null hypothesis is greater than or equal to 3, and your alternate hypothesis is less than 3. So you want the efficiency to be increased by more than 3. So we have 4 steps that we have to take to carry out this hypothesis test, which is number 1, formulate your hypothesis, being a null hypothesis and an alternate hypothesis. You can calculate your t-statistic, calculate cutoff values for the t-statistic, and check whether the t-statistic falls within the rejection range. So we're going to reject the null hypothesis if X bar is way below 3, and we're going to reject the null hypothesis if the t-statistic is way below 0. And this is a one-tailed test on the left side. So what you want to do is you want to import SciPy to perform your scientific computations and import NumPy to perform your numeric computations. So we're going to get 150 samples. That's N is your sample size. X bar is your sample mean, which is 2.9. Standard deviation is 1.35. Mu is your population mean, which is 3. Alpha, which is your significance level, is 0.05. Degree of freedom is 149 because it's 150 minus 1. You're going to calculate your standard error. Standard error is standard deviation divided by the square root of n. Standard error is 0.11. Then you're going to calculate your t-statistic. Your t-statistic is x bar minus mu divided by standard error. So your t-statistic is going to be negative 0.907. You're going to calculate your critical t value. So t critical equals stats.t.ppf, and it's going to be, ppf is percentage point function. It's going to be alpha, comma, degree of freedom, and so your t critical is going to be neg 1.655. And now you're going to determine if the t-statistic falls in the rejection region. So reject null equals t-statistic is less than t-critical, and that's false because your t-statistic is negative 0.907 and your t-critical is negative 1.655. So t-statistic is less than t-critical. And let's see what it looks like when we made a diagram of that. So the t-distribution is blue. You can see your rejection region is neg 1.66. Your t-statistic is neg 0.91, and your z-critical is negative 1.66. So your t-statistic is before the rejection region. And since it's before the rejection region, you cannot reject the null hypothesis. So you've got t-statistic is less than t-critical, which is false, which isn't true. So that's how you do that one. So it's a little bit difficult to do, and then you have to do it with trial and error. And the last one that we're going to do is the average men MBA students across various MBA programs in the U.S. is greater than 28 years. Collect data on average ages of men students across a sample of 40 MBA programs in the U.S. So the null hypothesis is mu is less than or equal to 28, and the alternate hypothesis is mu is greater than 28. So we're going to import SciPy to perform our scientific computations, NumPy to perform your numeric computations, and Matplotlib to visualize the data. So X bar, which is your sample mean, is 28.105. STD is your standard deviation, is 2.9747. Mu is your population mean, which is 28. N is your sample size, it's 40. Alpha is 0.05, that's your significance level. DF is your degree of freedom. That's going to be 39 because it's going to be n minus 1. So what you want to do is you want to calculate your standard error, which is the standard deviation divided by the square root of n, and your standard error is going to be 0.47. Then you want to calculate your t-statistic. Your t-statistic is x bar minus mu divided by SE. So that's going to be 0.22324. Then you want to calculate your critical t values. So t critical equals ADS, and this is going to be a one-tailed right test. So it's going to be ADS stats.t.ppf alpha, comma, df, and your t critical is going to be 1.68. And then we're going to determine if the t-statistic falls in the rejection region. So reject null equals t-statistic greater than t-critical, and that's false. The t-statistic is not greater than t-critical. So that means that you cannot reject the null hypothesis. So that means the null hypothesis is you can't, mu is less than or equal to 28. So you can't, and we've got an X bar of 28.105, but it says you cannot reject the null hypothesis. So what we did is we used matplotlib to make a drawing of this, and so you can see you've got your t-distribution, you've got your rejection region, you've got your t-statistic, which is 0.22, and you got your t-critical, which is 1.68. And so you cannot reject this. The t-statistic is within the acceptable value. It's not within the rejection region. So you can't reject the null hypothesis. So it gets it's a little bit tricky, and you have to experiment a lot with it, which I've been experimenting a lot with it. And it's hard work because there's rules about whether you're going to use the two-sided hypothesis test or a one-sided hypothesis test, whether it be a right side or a left side. And there's rules about how you do it. And I think the last video I made, I gave instructions on how to do that. But you just have to keep practicing and keep doing it. And then after a while, you get the hang of it, which that's what I'm trying to do. I'm trying to get the hang of it as well. So I've covered everything that I wanted to cover. I covered all of the hypothesis tests that I've done, so you can see them. So if you like my video, please like and subscribe. And thank you so much for watching my video. And I look forward to making more videos for you of a technical subject.